Ladies and gentlemen of Algebra 2, this is 1-6. We are nearing the end of Unit 1, and today we're talking about matrices. Matrices kind of are an organization of numbers, and the way they work is that they represent a set of numbers in a given way. So if we kind of take here, a matrix is going to have a set of numbers, so it could be like 3, 4, 5, -2, 1, 0, 17, 11, and -12. So this would be considered a matrix, and it's built like so. It's got a bracket on each side, and some row of numbers, and some column of numbers. Now, you're not limited to, this would be considered a 3 by 3 matrix, but you're not limited to that. You could have 2 by 4, you could have 4 by 1, you could have a lot of different things. Order is kind of how we say how big the matrix is. So you go row by column. I know it's kind of hard to remember. It's just R by C, row by column. So you count top to bottom, and then so you count top to bottom and then left to right. So it's kind of backwards of what you might think, and it's you're going to count the rows first and then go by the column second. Okay, and we're looking here. This would be a matrix right here. All right, and so what we're looking at is this. This would be considered a 3 by 4 matrix, 3 rows, 4 columns. So you're right, columns first, rows second. So this would be a 3 by 4 matrix. So if it says R3C1, what that really means is what's in row 3, column 1. So this would be 1, 2, 3, 4. Row 3, column 1, that would be 3. Row 1, column 4 is going to be right there, so that's going to be 2. So addition and subtraction matrices, it's easier than you think. All you have to remember is this, is that they have to be exactly the same size, and they have to have the exact same order. That's what that means. Otherwise, adding is kind of exactly what you would think it would be. So when I do this, it's going to be 2 plus 6, 5 plus 3, 1 plus 2, 4 plus 1. So final answer here is going to be 8, 8, 3, 5. That would be my answer. All right, all I'm doing is adding what's in the same location. Let me say that again. Add in the same location. So when I look here, subtracting, same kind of idea. I'm going to end up taking 9 minus 6, 2 minus 3, -3 minus 2, 0 minus 4, 5 minus 7, that's a 5, believe it or not, and then 1 minus a -3. So that's going to be 3, -1, -5, -4, -2, 4. That would be my full answer. Notice it's also the same size as the ones I'm dealing with, okay? So these are going to be 3 by 2, 3 by 2. My answer should also be a 3 by 2. Again, row, column. Row by column. So multiplying by a scalar, what happens? Well, all you do is basically you're going to double what's ever in there, okay? So it's kind of like saying A plus A. So without using addition, basically you're going to take 2 times everything. So you would just double, so you just multiply the scalar times each part, or each number. So if you're trying to figure out 3A, well, all that's going to be is 3 times everything. So that's going to be 3 times 2, 3 times 8, 3 times 1, 3 times 3, 3 times 5, 3 times 4, 3 times -1, 3 times 0, 3 times 7, 3 times 6, 3 times -2, 3 times 9. Boom. So when you look, what does this become? Well, let me slide it up here so we can look. So this becomes 6, 24, 3, 9, 15, 12, -3, 0, 21, 18, negative 6, 27. There would be my fully scaled vector, my fully scaled matrix. And again, this would be a 3 by 4 matrix, 3 rows, 4 columns. So if you take a look here, I want to take D plus E. So that means I'm going to take this one plus this one. So when I do this, I'm going to just match up everything. So 1 plus 1, 4 plus 1, 8 plus 1, 3 plus 4, negative 4 plus 3, 7 plus 2, 4 plus 4, 5 plus 3, negative 9 plus 2. Boom. So just match up what is in the same location all the way through. They're both 3 by 3, so I can put it together, so I put it together. So when I look, so this becomes 2, 5, 9, 7, negative 1, 9, 8, 8, negative 7. Boom, boom. There's my answer. All right, notice everything is a 3 by 3, so boom, there we go. So if I take a look here, 2b plus f, so b and f are the same size, so I can put those together. All right, so I can take double b, so that's going to be, so this will be 6, this will be 30, this will be negative 16, plus 12, negative 4, 16. So this becomes 18, this becomes 26, this becomes 0. There's my answer, okay? Negative 16 and 16 go together, and you still have to put a number here, okay? You still have to put a 0 there. It doesn't go away just because the numbers go away, so make sure you do that. So I double everything here, add everything, and then put together what I got. So taking a look here, f minus b. All right, so now I'm kind of flipping things around, so that becomes 12, negative 4, 16, minus 3, 15, negative 8. There's my answer. So that becomes 9. That's going to become negative 19. This will become 8. There is my 1 by 3 answer. So last one here, negative 3e plus minus d. So negative 3e, exactly what it sounds like. So this is going to really be negative 3, negative 3, negative 3, negative 12, negative 9, negative 6, negative 12, negative 9, negative 6. Okay, so this is the negative 3e minus d stays the same, 1, 3, 4, 4, negative 4, 5, 8, 7, negative 9. So now putting that together, I kind of just subtract what's in the same location. So here's what I get. I get negative 4, I get negative 7, and I get negative 11. This would be negative 15. This would become a negative 5, negative 9 minus negative 9 minus negative 4 is going to be negative 5. Negative 6 minus 7, negative 13. Negative 12 minus 4, negative 16. Negative 9 minus 5 is going to be negative 14. Negative 6 minus negative 9 is actually going to become positive 3. So here's my final answer. That's what that matrix is going to look like. All right, so play around with this a little bit. Big topic here is to remember it's row by column. And then basically if it's a number out front, multiply it by everything. If it's addition or subtraction, you do that operation on the numbers in the same location. All right, so take a look. Come talk to me with questions. Have a good day.